Here, we are going to verify whether the given transformation is considered as a linear transformation. We have here from R2 to R2, given by this transformation, T of x sub 1 and x sub 2 is equal to x sub 1 plus 2x sub 2, and then minus x sub 1 and minus x sub 2. To verify where this is a given linear transformation is really a linear transformation, we need to establish these two conditions. The first condition is when the transformation of a certain sum, let's just say here x and y, is equal to the transformation of x plus the transformation of y. We need to verify this to say that we are now one step closer in telling this linear transformation. The second condition is when we are going to have the transformation of a product of a certain scalar and x is equal to the scalar times the transformation of x, vector x. Okay. By the way, these are vectors here. Okay, so let me make this thicker. This is a vector as well. Alright, so we are just going to show the equality of this, and then we can say that the given is a linear transformation. So to do that, let us have the x vector. Since it's in R2, let's have x sub 1 and we have x sub 2. Okay, so that would be similar to the given. And let's have another vector. Let's have vector y sub 1 and y sub 2. So for the first condition, we need to show that this will really hold. So we have here the transformation of the sum of the two vectors. Okay, we need to reach this equality here. So in this case, using the vectors, the entries of the vectors, you have x sub 1, x sub 2, plus y sub 1, y sub 2. Before we take the transformation, let's take their sum. You have x sub 1 plus y sub 1, and you have here x sub 2 plus y sub 2. So from here, since we have two entries now, we are going to use now the given definition of its transformation. So we'll have it here. So x sub, the first entry is this one here, x sub 1 plus y sub 1 plus twice the second entry, twice x sub 2 plus y sub 2. And the second will be minus x sub 1 plus y sub 1. And then you have here minus x sub 2 plus y sub 2. From this, let's try to manipulate this one here, and we need to reach again this point. So let me use the spaces at the bottom. Of course, by distributing these two here and this negative, these two negative by the way, you will have here x sub 1 plus y sub 1 plus 2x sub 2 plus 2y sub 2. The other side, you have negative x sub 1 minus y sub 1 minus x sub 2 plus y sub 2. Since our goal is to come up with the sum of the two different transformations, let's take all entries of the x vector into one group, and then for the y vector into the other group. That would mean here x sub 1, I'm going to write this first, plus 2x sub 2 plus y sub 1 plus 2y sub 2, and it's possible because we're just interchanging them. On the other side as well, minus x sub 1 minus x sub 2, sorry, my bad, this is actually minus because we distributed the negative sign here. So we have minus y sub 1 and minus y sub 2. Then from that, let's separate the entries into the sum. We have here sum here, but if you would like to, you could even do it like this. You're going to group the entries of the x vector, y sub 1 plus 2y sub 2. In the other side as well, group them, negative x sub 1 minus x sub 2. You can use here plus. This will become still negative y sub 1 and negative y sub 2. Okay. Then we group now the entries including for x and y. you will have here x sub 1 plus 2 x sub 2, and your minus x sub 1 minus x sub 2 plus y sub 1 plus 2y sub 2 negative y sub 1 negative y sub 2. This is actually the actual definition here, okay? And that is actually the equivalent for the transformation of the x vector itself. Okay? And this is also for the y vector as well. Now that we have satisfied the first situation, let's proceed in moving to the second condition here. Again, we're going to let C as any scalar. Okay? And with that, we can have here T, C, let's have vector X. And hopefully we could reach at this point. So this would mean T, C times the component of your X vector, X sub 1 and X sub 2. Distribute that, you have C x sub 1, C x sub 2. And then, we are now going to apply the definition of its transformation. So you will have here the first entry, Cx sub 1 plus twice the second entry, Cx sub 2, then we have minus the first entry, Cx sub 1 minus Cx sub 2. We can factor here the scalar. So you have x sub 1 plus 2x sub 2. We can also factor here the scalar C, negative x sub 1, negative x sub 2. Since both scalars are found in both components of our transformation, we can take it out. And you have here x sub 1 plus 2x sub 2, negative x sub 1 minus x sub 2. And this is actually the definition itself. So we can say here, this is just C times the transformation of your vector x. So we have satisfied both conditions. This would mean that the given expression is a linear transformation. So just need to verify these two conditions so that you would know the correct operations to be used, and of course algebraically all the operations that is present in each process. Thank you very much for watching.